A solid forms when two aqueous solutions are mixed. This solid is called a catalyst, a solute, a precipitate, or a solvent. The answer is a precipitate, because a precipitate is an insoluble solid that gets formed when two solutions are mixed together in a precipitation reaction. Which of the following best describes a spectator ion? An ion that participates in forming a precipitate, an ion that changes oxidation state, an ion that appears unchanged on both sides of the ionic equation, or an ion that is produced during a reaction. The answer is an ion that appears unchanged on both sides of the ionic equation, because spectator ions don't participate in a reaction and remain unchanged. Which reaction forms water as the net ionic product? HCl plus NaOH, AgNO3 plus KCl, Na2CO3 plus CaCl2, or HCl plus AgNO3? The answer is HCl plus NaOH, because the HCl exists as H plus and Cl minus ions in solution, and the NaOH, Na plus and OH minus. The H plus and OH minus ions combine to form water, but the chloride and sodium ions remain as ions in solution, spectator ions. Which process involves formation of a new substance? Condensation, filtering sand from water, sublimation of dry ice, burning magnesium ribbon. The answer is burning magnesium ribbon, because burning is a chemical process and a new substance gets formed, in this case magnesium oxide. In a correct particulate representation of NaCl aqueous, the diagram should show NaCl molecules together, separate Na plus and Cl minus ions, a solid NaCl lattice, Na2 and Cl2 molecules. The answer is separate Na plus and Cl minus ions, because sodium chloride is dissolved in water if it's aqueous, and the ions in the ionic lattice have broken apart from one another and are freely moving around in solution, separated from each other. Which of the following involves only intermolecular interactions changing? Condensation of water vapor, combustion of hydrogen gas, decomposition of calcium carbonate, or the reaction of magnesium with hydrochloric acid? The answer is condensation of water vapor. This is a physical process. It only involves the changing of hydrogen bonding between water molecules. All the others involve the breaking and forming of intramolecular bonds such as covalent bonds and ionic bonding. When solid carbon dioxide sublimes, what occurs at the particulate level? Covalent bonds are broken, intermolecular forces are overcome, new covalent bonds form, or ions separate. The answer is intermolecular forces are overcome. Subliming or sublimation is when a solid turns directly into a gas. Because carbon dioxide is a molecular substance and is made up of molecules, those molecules are held together by intermolecular forces, and these intermolecular forces are overcome when solid carbon dioxide gets turned into a gas. When liquid nitrogen boils, what occurs? Nitrogen-nitrogen triple bonds break, N2 molecules form N4 clusters, only intermolecular forces are overcome, or new molecules form. The answer is only intermolecular forces are overcome, because nitrogen N2 is a molecular substance, and the molecules are held together by intermolecular forces. When molecular substances change state, it is intermolecular forces that are involved. In a titration of H2SO4 with NaOH, the equivalence point occurs when the moles of NaOH equals the moles of H2SO4 at the start, the moles of NaOH equals twice the original moles of H2SO4, the moles of NaOH added equals half the moles of H2SO4, or the moles of NaOH added equals 3 times the starting moles of H2SO4. The answer is when the moles of NaOH added equals twice the moles of H2SO4 at the start. Because 1 mole of H2SO4 releases 2 moles of H plus ions, it's a diprotic acid. This means you need twice the moles of sodium hydroxide compared to moles of H2SO4 for a complete reaction between the two. Which statement best describes the endpoint of a titration? It is always exactly the equivalence point. It is an observable event used to approximate the equivalence point. It occurs at pH 7, or it occurs when excess titrant appears. The answer is it is an observable event used to approximate the equivalence point in the titration. The observable event used is often a color change from an indicator. The indicator changes color when a certain pH of the solution has been reached, and if the indicator is chosen correctly, the pH at which the indicator changes color should be the same pH at when the equivalence point is reached in the titration.